Electricity. There are two types of electricity: current electricity, static electricity. Let's start with current electricity. What is electricity? Electricity is the flow of charge or electron. Here you see that the electrons are crossing this wire and they're lighting up this light bulb, and then it goes back to the battery. Fun facts about electricity. It's one of the most widely used form of energy. Electricity is so fast that it travels at the speed of light. Electricity can be made from all types of things, examples like coal, energy, natural gas, and oil. Lightning is actually a type of electric energy found in nature. Electricity is used to power our homes, lights, and electronics. Electricity can be made from a number of different resources. There are both renewable and non-renewable resources. Examples of renewable resource would be nuclear power, coal, and natural gases. And examples for renewable sources are sun, wind, water, biomass, and geothermal power. We saw that electricity is flow of charge or movement of electrons between atoms. Just a quick few information about atoms. Atom is what makes up matter. So the atoms are made of electrons, neutrons, protons. The neutrons and protons together make up the nucleus. The electrons are the ones that are rotating on the orbit or shell around the nucleus. Like you see in this picture, in this video, these are the shells, and this is where the electrons move. There are up to 118 types of atoms. To make it easier to understand them, they have been arranged in something called a periodic table. This is a periodic table with all the elements arranged in rows and columns. So let's see an example of one atom, that's the carbon atom with a number 6. This number represents the atomic number of this particular atom. The number that you see on the top is called the atomic number. And 6 atomic number atom has 6 protons, 6 electrons, and 6 neutrons. These electrons, let's see how they are arranged in an atom. Each shell can contain a particular number of electrons. The first shell can have 2, the second can have 8, and the third can have 18. This way of arrangement of electrons around the nucleus is called electronic configuration. Let's see the electronic configuration of carbon atom. So we know that the carbon atom has an atomic number of 6. Yes. So we will draw a nucleus and then we'll draw the first orbit. And remember, the first orbit can hold 2 electrons. So we draw those 2 electrons, and how many are left? In 6, there are 4 left. So in the second orbit, we will draw 4 of the electrons. So that in total makes 6 electrons. So this is a carbon atom. Let's see one more example of a copper atom. What's the atomic number of copper atom? It's 29. So let's start drawing a copper atom. So first you'll draw 2 in the first shell. The second shell can hold 8. So that makes a total of 10. How many can the third shell hold? It can hold 18. So that makes a total of 28. 2 plus 8 plus 18 makes 28. How many are left? One more left. So we'll have to draw one more shell just for that one electron. So that is a copper atom. We drew 2 electrons, yes, and then in the second shell we drew 4 electrons. That makes it a total of 6. But remember, second orbit can hold a maximum of 8 electrons, but in here there are just 4. So that makes them a free electron. They can also be called valence electron. So these valence electron can actually move around. They are not bound to the atom. That's why they are called free electrons. Remember, we learned electricity is flow of charge or movement of electrons between atoms. So after learning what a free electron is, we can understand that the free electrons are the ones that help with the flow of electricity. If you watch this video in here, this is a zoomed picture of a wire. You can see how the free electron is jumping around from one atom to another. That's what helps with the flow of electricity. Clear? Generally, the atoms have a neutral charge. That is, they have equal amounts of electrons and protons. So the net charge is basically zero, because we saw, remember, if we saw in our previous slides, if there are 6 electrons, there has to be 6 protons as well. That's how an atom usually is. But sometimes an atom can gain an electron. That's when it becomes a negative ion. So an atom, when it gets more electrons, it becomes a negative ion. But when it loses electrons, it becomes a positive ion. A negative ion is when the atom gains more electrons, and a positive ion is when an atom loses an electron. Now let's see what's a circuit. A circuit is a device made of other smaller electronic devices like these that can help with the flow of electricity through itself to power some larger devices. And every electric circuit must have a power supply. The power supply could be in the form of a battery or a power plant. And electricity can flow only when there is no gaps in between. For example, in here, you see this is a closed circuit. That's why the electricity is flowing. But when there is a gap, it becomes an open circuit. Why do charges flow through a circuit? Why does it have to flow? When you use a battery, we know that it can light up a bulb. How does it work? This is because there's a difference in the potential energy. For now, just understand that the battery has a higher potential energy in here and a lower potential energy in here. And we also know opposites always attract. Because in nature, anything higher will always move to a place where there is a lower charge. We have learned in our previous chapters that high pressure and low pressure always have to balance out. So, the currents flow from a point of higher potential energy to a point of lower potential energy. Okay, what's potential energy? Potential energy is the stored energy that depends upon the position of an object. What's kinetic energy? Energy possessed by an object in motion. Let's see more example pictures to understand potential and kinetic energy. So now we are done with current electricity. Let's move on to the static electricity. What's static electricity? It is created when the positive and negative charges aren't balanced. The protons and neutrons don't move around much because they form the nucleus. Yes, the protons and the neutrons, they form the nucleus. But electrons love to jump all over the places. So in here, you're seeing a person walking and he's collecting all the electrons from the carpet, which leaves the carpet positively charged. But then when the person goes and touches a doorknob, all those negative electrons that he collected has to leave his body, because in nature everything has to be balanced. So when it leaves the body, that's when you get the static shock. Opposite charges attract, same charges repel. This is called electric force. Lightning is a form of static energy. How does lightning occur? When there is layering of clouds, lightning happens. As the ice particles and the water droplets rub and bump against each other, they become electrically charged. That's the positive and negatives. The negative charges are formed in the lower cloud and the positive charges are formed in the upper cloud. When the upper and the lower cloud stores tremendous amount of charge, the charge has to be transferred, because we learned, remember, positives and negatives attract. The lightning that we see in the sky is due to this charge transfer, because positive and negative, they have to basically exchange. That's what causes the lightning. But how does the lightning reach the ground? The objects on the ground are positively charged. When the charge stored in the lower cloud of the ground is tremendously increased, you see that there is so much negative in here. The charge has to get transferred, yes? So the charge is transferred between the lower cloud and the ground. That's what creates lightning. Different types of static electricity. You can do a small experiment at home wherein you take a balloon and rub on your hair and hold it a little away from your hair. You'll see that your hair is trying to basically gets attracted to the balloon. That happens because you are taking, while you're rubbing the balloon, it picks up all the negative charges and your hair is left with positive charge. So because the positive and the negative attracts, that's why the hair try to move towards the balloon.